Good afternoon everyone, welcome to the channel. Today I want to talk about principal component analysis, in short which is known as PCA. This is another dimensionality reduction method, but this is a linear one. In my previous two videos I talked about UMAP and TSNE. Those are non-linear dimensionality reduction techniques, but this is a linear one, and I will perform PCA today using another dataset from sklearn, the breast cancer dataset. So let's get started. At first I want to give a header. Center. Okay. Principal component analysis. In short, PCA. Okay. At first I want to import the required libraries. So we will obviously need pandas, numpy, matplotlib as well, so these are our required libraries. Now let's load sklearn's breast cancer dataset. So cancer datasets, load breast cancer. Data will be cancer.data, labels will be cancer.target. Let's create a data frame. Okay, pd.dataframe. This will be data, and we want to also add the classes as well. Labels df.head. So there are 30 features starting from 0 to 29, and the last one is the classes. We can also check the shape. So 569 samples, 30 features, and last column is obviously the classes. Now let's separate the features and labels. So for separating features from our data frame, we need to drop the last column. So let's drop it. And classes, we only need the last column, all rows and column name. Okay, features dot shape. So from here we have dropped the classes. Now perform preprocessing. create an instance, scaled features, scalar.fit transform features. Now let's perform 2D PCA at first using two components. So create an instance, PCA, and components will be 2 for 2D, random state 0. PCA 2D fit transform scaled features. Okay, we can confirm from the shape. So from 30 features we have reduced them to 2 features. Let's see them as well. So you can see every sample has now 2 components. Let's check the variance by each component. PCA 2D dot explained variance ratio. So the first component captures 44% variance. Second component captures 19% variance of the overall distribution. np.unique. Let's check the unique labels. So we have two classes, 0 and 1. 0 is malignant cancer and 1 is benign tumor. Let's separate the columns as well. Reduced to D. 0 component, this will be 1. Let's create a color tick. So let's red and blue. Label dict. So 0 is malignant, benign. Marker dict is 2 different markers. Finally alpha dict. 0. Now let's visualize. Light gray for I in np.unique classes. np.where classes I scatter plot color dict I I. So ax dot set x level, let's say PCA 1, font size 15, copy, and for y level as well, PCA 2, title 2D visualization using PCA 20. Final legend, title will be breast cancer. Font size 20, title font size is also 20. So this is our 2D visualization for this breast cancer dataset that's available in sklearn. So we have reduced the features from 30 to 2, then visualized them. This is a linear dimensionality reduction method using principal component analysis. So we can do this for 3D case as well. So let's perform 3D PCA. I have to copy these two lines. This will be 3D, and components 3 for 3D. Let's check shape. So previously we had 569.2, now 569.3 for 3D, reduced 3D. So you can see each sample has 3 components. So PCA 3D explained. So the first component captures 44% variance, second on 19% variance, third on 9% variance of the overall distribution. So let's separate the components. 3D, this will be 3, and this will be 2. Now this big block of code, Control C. So we have edit. This will be white. This will be projection. 3D, COM33J. Let's bring it down. PCA 3. This will be Z level. This will be 3D. 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 3 Okay, so this is our 3D visualization. I think this became a little bit close, so let's point 0.64, let's 0.55. Yes, now it's slightly wider. So this is our first component, second component, third component. 3D visualization using PCA. Here we have visualized it using 2D. I think I forgot to mention these here. Okay, now these dots are bigger than the previous one. So that's how we can perform PCA and reduce dimensionality. And this is a linear reduction. Previously TSNE and UMAP that I showed were non-linear. Okay, so I think that's the end of this video. Thanks for watching.